Let's solve one more examples before we move to the next questions. So here they said we have integral over 1 minus sine square 3t cos 3t dt. You know, I told you the first thing to be considered. You can do this one in two ways, or if you like, you can represent this one to be a single variable. Then, or if you like, you can just make use of, or maybe you should just use that one. I can just say let u, or you can open the bracket. If you open the bracket too, we are still going to have the same result. Or maybe if you just make use of that, I can say let u equal to sine 3t. You know that one, if that one is u, that means what we have here is integral over 1 minus u square then cos 3t dt. Or if you like, you can use the other method I applied earlier. Use this to open the bracket, but this another way, and we're going to have the same result. So u and t, here we have the u dt is equal to integral of sine 3t, and we have cos 3t. 3 cos 3t rather. So I want to make this on the subject. If I make this one on the subject formula, so here we have the t is equal to 1 over 3 cos 3t, then we have du. So now let's put it back there. So here now we are going to have integral of 1 minus u square cos 3t. So our dt now is this. So if I substitute, that means we have 1 over 3 cos 3t dt. You can see this can cancel this. So I have 3 left here. If I pull it out, we have 1 over 3, 1 minus u square, sorry, this is du. So we have du. Now, I hope you are following, right? So now let's just integrate respect to u. So integral of 1 respect to u, we have u, respect to u, we have u3 over 3. So now, but our u something, our u is sine 3t. So here we have 1 over 2, 1 over 3 sine 3t minus this one too, that is a sine cube 3t over 3. So now if I like, I can open the bracket. This times this, we are going to have sine 3t over 3. This time this, we have sine cube 3t all over 3 times 3, you are going to have 9 then plus c. So that's all about what we have for trigonometric functions using our integration of our trigonometric functions. So now the next one we are going to talk about is exponential. You know, if you recall under the differentiation we have exponential too. So here too we also have exponential functions. So let's see how we are going to talk about that. For example, we have integral of e raised to the power of x dx. You know, integral of e raised to the power of x, this is nothing but e raised to the power of x plus c. Just like we are taking the powers, let's say I have integral of e raised to the power of 2x, for example. This is nothing but e raised to the power of 2x over 2. If you wonder, now how did I got this? So let me just show you. If I have integral of e raised to the power of 2x dx, the first step, just like a use substitutions. Use substitution is very, very important. So I will just let the use substitution to be, I'll let u to be the power. You can just say let u equal to 2x. So if that one is u, that means that we have integral of e raised to the power of u dx. So here we have u and x, and we have du dx is equal to 2. So now I want to make my dx as a subject. That means that we have the x is equal to 1 over 2 du. So going back here, we have integral of e raised to the power of u. So dx now is 1 over 2 du. So if I pull out this, we have 1 over 2 integral of e raised to the power of u du. So integral of e raised to the power of u is nothing but e raised to the power of u. And our u is 2x. That means that we have 1 over 2 e raised to the power of 2x plus c. You can see that it's the same result. Even if they said integral of e raised to the power of 5x plus 1 dx, you know, integral of 5x, that one is going to be 5. Of course, tan which is 1 is going to be 0. Then we have e raised to the power of 5x plus 1, then plus c. So what if it now comes in this way? Let's see another forms. Let's see another way. If it's coming another way, let's say I have something like this. Maybe they said integral of cos x e raised to the power of sine x dx. You see the way it comes here? I can still follow the same process. Just target the power. Just say let u equal to the power. You can see the power that we have is sine x. So let u is equal to sine x. So if u is equal to sine x, so that means we have this one to be integral over cos x e raised to the power of u dx. So here u and x, and we have du dx is equal to cos x, right? So if I have dx now, I can have dx to be 1 over cos x, then we have du. So I can put it here. That means that we have integral over cos x e raised to the power of u. Now, our dx is nothing but 1 over cos x du. So now, cos x can cancel cos x. So that means that we have integral over e raised to the power of u du, right? So e raised to the power of u now, e raised to the power of u, as I told you earlier, is nothing but e raised to the power of u. And our u that we have is sine x. So that means here that we have is e raised to the power of sine x, then plus c. So let's see the question from these materials. Okay, here it's in forms of it's the same problem, but they only said integral of pi over 2 0 e raised to the power of sine x. I think it's the same questions. Cos x ds. Luckily, it's the same questions. So now you can see this one is definite because it has the upper limit and lower limit. So luckily, we have already got the result. When we integrate this, what do we have now? You can see what we have. What we have is e raised to the power of sine x. Then we just put the upper limit is pi over 2 and the lower limit is 0. So meaning here is the first one, upper limit, when x is pi over 2 minus when x is 0. So that means here I can have e raised to the power of sine x. Our x is pi over 2. Then minus e raised to the power of, then the other one is sine 0. So here I can have e raised to the power of sine pi over 2. Pi over 2. Pi over 2 is nothing but pi over 2 times 180 over pi. If you missed our previous video on how to conversion of radian to degree or degree to radian, whenever you have a value in radian, you want to convert it, you just multiply it by 180 over pi. So this can cancel this. 2 here 1, 2 in 180, we are going to have 90. So then what we are talking about here is sine 90 degree minus e raised to the power of, if you check your calculator, sine 0 is nothing but 0. Right? So then if sine 90 is what? Is 1. So that means that we have e raised to the power of 1 minus e raised to the power of 0. Any number raised to the power of 0 is 1. So e raised to the power of 0 is 1. So that means what I have here is e minus 1. So let's see. Like this one too. So if it's another one, just like the way we treated another out of the differentiations, we're still going to apply something similar here. We're still going to apply something similar here. Meaning, if I have like 2 raised to the power of x dx, if it is ordinary exponential, we say it's going to be 2 raised to the power of x. But since it's not e, then this one is going to be ln 2. Ln of the powers of the base that we are talking about. Like for example, they said integrate 2 raised to the power of sine x cos x. So we are under exponential cos x dx. Sorry about that. So the same process, I'll just let it know, that is let u equal to sine x. So if u is equal to sine x, that means that we have this one to be integral of 2 raised to the power of u cos x dx. I hope you are following me, right? Yeah. So u and x, we have du dx is equal to differential of sine x, and we have cos x. So here we have dx is equal to 1 over cos x du. So if I put it here, that means that we have integral of 2 raised to the power of u cos x. Our dx is this. So that is 1 over cos x du. So this can cancel this. Recall, what I have now is integral of 2 raised to the power of u. That means it's the same thing as 2 raised to the power of u over ln 2. And our u is sine x. That means here we have 2 raised to the power of sine x over ln 2, then plus c. So let me solve one more so that you get it better. To say prove that, here we have to prove. So let's see the provings, if it's going to work. It says show that integral of pi over 4 to 0 for 1 plus e raised to the power of tan theta sec square theta d theta. You said we should prove that if this is equal to e. It's just a packaging, it's just so simple and straightforward. Just follow the same process, the same patterns of how we can approach the results. So how are we going to do that? Just let the powers, what we have at the powers, let the power to be a single variable. That is, let u equal to tan theta. Or if you like, you can open the bracket, this times this, this times this. But I think this one is another simplest way of doing that. So that means this one will now become integral over pi over 4 to 0, 1 plus e raised to the power of u, then sec squared theta d theta. I hope you are following, right? It's not all the time that it's always going to be x. It can be any variable. It can be x, it can be y, or it can be z. So u and theta, we have du d theta. Recall that when we are differentiating with respect to theta, when we are differentiating tan theta is sec square, right? So differential of tan, that one is sec square theta. So what we are interested in is to make our sec as the subject, as this theta as the subject. If I cross multiply, that means that we have du is equal to sec square theta d theta. I hope you are following, right? So I want to make my d theta as subject, divide all through by sec square theta. So if this cancels this, that means that we have d theta to be 1 over sec square theta du. So now let's substitute it back to these values. So down here we have integral over pi over 4 is 0, 1 plus e raised to the power of u sec square theta. So now our d theta now is nothing but 1 over sec square theta. Then we have d. So this can cancel this. Then here we have integral over pi over 4 to 0, 1 plus e raised to the power of u du. So now we want to integrate this function now. And after the integral of 1, we have u. Integral of this, we have e raised to the power of u. Then upper limit is pi over 4, and the lower limit. You can see, in most cases, in this case, u substitution is very, very important. You have to make sure, you have to know how to make use of u substitutions. So now, so if I substitute that one, let me just cancel this area here. So my u is tan. That means that we have tan theta plus e raised to the power over tan theta. Then we have pi over 4 and 0. So as usual, since it's definite, I will put for the upper limit minus for the lower limit. So for the upper limit, what we have is tan pi over 4 plus e raised to the power of tan pi over 4. That's for the upper limit. Then minus for the lower limit now, tan 0 plus e raised to the power over tan 0. So now, tan pi over 4, I've already told you how to convert that one. Pi over 4 is nothing but pi over 4 times 180 over pi. So this cancel this. 2 here, that is 90, that is 45. So that means what I have here is tan 45 degree plus e raised to the power of tan 45 degree. The minus tan 0 is going to be 0. E raised to the power of tan 02 is going to be 0. So what we have left is 0. So tan 45, we press the calculator for tan 45. Tan 45 is nothing but 1. So this is 1 plus e raised to the power of 1. If I minus this one, e raised to the power of 0 is going to be 1. So I have 1 here. So 1 minus 1 is going to be 0. So all we have left is e. So that means the requirement is satisfied. So integral of pi over 4 to 0 for 1 plus e raised to the power of tan theta sec square theta d theta, the result is equal to e. So that's all about what we have for exponential functions.